Picture this, a planet drifting alone through the endless blackness of space, untethered to any star, yet somehow screaming its existence into the void with signals no one can explain. These cosmic orphans, known as rogue planets, shouldn't be able to make a sound, yet they do, and what they're telling us defies everything we know about how the universe works. Right now, as you watch this, there are worlds wandering the darkness between stars, sending out pulses, hums, and bursts of energy that leave scientists scratching their heads. Some of these signals repeat like clockwork, others flash just once and vanish forever. A few even seem to carry patterns that look eerily deliberate. Today, we're diving into 25 of the strangest, most baffling signals ever detected from these rogue planets. From harmonic hums that sound like alien choirs to bursts of energy that flicker like a cosmic SOS, each one is a mystery waiting to be unraveled. So buckle up, because by the end of this journey, you'll never look at the empty spaces between stars the same way again. Now let's turn our attention to the first of these cosmic enigmas, a signal so peculiar it sounds almost like a heartbeat in the dark. Meet OGLE-522, a rogue planet roughly 80 light-years away, and the source of what scientists have dubbed the Lonely Pulse. This isn't just random static, it's a rhythmic, repeating signal, beating out a steady pattern like a metronome lost in space. The pulse repeats every 2 hours and 7 minutes with eerie precision, a consistency that rules out chaotic cosmic events like asteroid impacts or magnetic storms. What makes this even stranger, rogue planets aren't supposed to have a pulse. Without a star's energy to power atmospheric disturbances or auroras, these worlds should be silent. Yet OGLE-522 is anything but. So where's this sound coming from? One leading theory points to an incredibly powerful magnetic field. Some rogue planets, especially younger ones like this, might still retain swirling molten metal in their cores, generating magnetic fields far stronger than Earth. If charged particles from the interstellar medium collide with this field, they could create rhythmic bursts of radio waves, essentially turning the planet into a cosmic lighthouse. But there's another, even wilder possibility, a hidden moon. Imagine a massive exomoon locked in a tight orbit around OGLE-522, its gravity tugging at the planet's magnetosphere like a violin bow on a string. Each pass could generate that 2-hour pulse, a celestial duet between two unseen bodies. It's a tantalizing idea, considering we've yet to confirm an exomoon around any rogue planet. Here's what really baffles researchers, though. Even if one of these theories is correct, the signal's sheer clarity defies existing models. Magnetic interactions should produce static or erratic bursts, not clean, musical pulses. And a moon's gravitational pull would likely create subtle variations in timing, yet this signal is as precise as a Swiss watch. Could there be something else at play? An unknown form of planetary resonance, or even dare we say it, a structure on or around the planet amplifying the signal. For now, OGLE-522 keeps its secrets, its lonely pulse echoing through the void, daring us to listen closer. And this is just one of the mysteries we're about to uncover. Now let's drift deeper into the cosmic unknown, where silence is rarely what it seems. Just a few hundred light-years from where we left off, another rogue planet refuses to stay quiet. CFBDSIR 21490403, a frozen world with a signal so faint, it feels less like a broadcast and more like a secret whispered across the void. Unlike the steady pulse of OGLE-522, this signal is elusive. It flickers in and out, a repeating radio echo so soft that scientists almost missed it entirely. Imagine tuning an old radio between stations, catching snippets of a distant voice before it fades again. That's the eerie quality of this transmission. What's baffling is the rhythm. Unlike random cosmic noise, these whispers repeat every 47 minutes with ghostly consistency, as if the planet itself is murmuring on a loop. So what could possibly produce such a delicate signal from a world without a star? One compelling explanation points to atmospheric ionization. CFBDSIR 2001-149-0403 is what's known as a free-floating brown dwarf, a failed star with just enough heat to sustain a thin, turbulent atmosphere. As charged particles from deep space cosmic rays or interstellar wind collide with this atmosphere, they might ionize gases like hydrogen or methane, creating fleeting bursts of radio waves. Think of it like the crackle of static electricity, but stretched into faint, rhythmic whispers by the planet's slow rotation. Then there's the interstellar medium theory. Rogue planets like this one aren't truly alone. They drift through clouds of dust and plasma. If CFBDSIR 2149-0403 magnetic field interacts with these particles, it could generate repeating ripples of energy like a boat's wake echoing across a pond. Some researchers suggest these interactions might even amplify naturally, creating resonance waves that explain the signal's strange regularity. But here's the twist. Neither theory fully accounts for the whisper's clarity. Ionization should produce chaotic bursts, not orderly echoes, and interstellar interactions usually scatter signals into noise. That's led to a more speculative idea. Perhaps the planet's atmosphere isn't uniform. Hidden beneath its icy exterior, layers of metallic hydrogen or exotic ices could act like natural radio mirrors, bending and focusing the signal into those eerie, repeating whispers. The most haunting detail: no one knows if these whispers are new or ancient. Without a star to mark time, CFBDSIR 2149-0403 could have been murmuring this pattern for millions of years, unheard until now. It's a reminder that even in the vacuum of space, nothing is truly silent, just waiting for us to listen closely enough. And as we'll see next, the cosmos has even louder surprises in store. Just when you thought space couldn't get any stranger, along comes SIMP J013656663 plus 0933473, a name as wild as the signal it blasted across the cosmos. This rogue planet, an ultra-cool dwarf barely clinging to stardom, didn't whisper or hum. It screamed, a sudden, violent burst of energy, over 10,000 times brighter than anything it had ever emitted before, lit up telescopes for mere minutes before vanishing like a cosmic firework. Unlike the rhythmic whispers of CFBDSIR 2149-0403, this was chaos unleashed. Imagine a thunderclap in a silent room. That's the shock this burst delivered to astronomers. What makes it so baffling? Ultra-cool dwarfs are supposed to be cosmic couch potatoes, drifting through space with barely a flicker of activity. Yet SIMP J013656663 plus 0933473 defied expectations, producing a flare so intense it rivaled those of younger, hotter stars. One leading theory points to auroras, but not the gentle northern lights we know. On Earth, auroras happen when solar winds dance with our magnetic field. But this rogue planet has no star to whip up solar winds. So what's fueling the light show? Scientists suspect its own magnetic field might be the culprit. SIMP J013656663 plus 0933473's field is hundreds of times stronger than Jupiter's, and if it's tangled or shifting, it could snap like a rubber band, releasing colossal energy. Picture a cosmic short circuit with charged particles slamming into the atmosphere at unimaginable speeds, sparking a burst visible light years away. Then there's the cosmic trespasser idea. Rogue planets don't travel alone, they share the void with asteroids, comets, and maybe even black holes. If something massive, like a wandering asteroid or a tiny black hole, got too close, its gravity could have destabilized the planet's interior, triggering a massive release of pent-up energy. It's like stomping on a soda can. Pressure builds until it explodes, but here's the kicker. The burst spectrum didn't match typical auroras or impacts. Instead, it showed bizarre spikes in infrared and radio waves, suggesting something even more exotic, like a magnetic reconnection event where field lines break and realign, unleashing energy equivalent to millions of atomic bombs. These events are common on the Sun, but on a rogue planet, unprecedented. And just like that, the burst was gone. No repeats, no warnings, just a fleeting cosmic tantrum that left scientists scrambling. Was it a one-time cataclysm, or is SIMP J013656663 plus 0933473 hiding more surprises? One thing's certain. The universe loves proving we've barely scratched the surface of its secrets. Up next, a pair of flickering rogue planets that move in eerie harmony, another puzzle waiting to unravel. Now, shifting our gaze from the chaotic outburst of SIMP J013656663 plus 0933473, we arrive at something far colder and far more mysterious. Meet WISE 0855-0714, the coldest known rogue planet in the cosmos, where temperatures plunge to a bone-chilling -450 degrees Fahrenheit. Yet, despite its icy desolation, this wandering world flickers, not once but twice in eerie synchronicity. These twin infrared flickers, captured by telescopes over a span of mere weeks, weren't random. They pulsed in near-perfect harmony, like a cosmic metronome ticking in the void. What makes this so puzzling? Rogue planets, especially frigid ones like WISE 0855-0714, aren't supposed to flicker at all. They're meant to be dark, quiet, and utterly predictable. So what's causing these synchronized flashes? Scientists are locked in a heated debate, and the theories are as fascinating as they are conflicting. First, the atmospheric disturbance hypothesis. Picture this planet's thin, methane-laced atmosphere as a blanket of simmering turbulence. When pockets of gas heat unevenly, perhaps from lingering geothermal warmth or interactions with cosmic rays, they could create sudden, localized bursts of infrared light. Think of it like bubbles popping in a pot of soup, each releasing a tiny flare. But here's the catch. For two flickers to happen in such precise rhythm, the atmospheric conditions would need to be improbably stable across vast distances. It's like expecting two distant thunderstorms to produce identical lightning strikes at the exact same moment. Unlikely, but not impossible. Then there's the internal heat anomaly theory. Deep beneath the frozen crust of WISE 0855-0714, there might lie a hidden engine, a residual core of molten rock or slushy magma, slowly churning like a dying ember. If this heat escapes in periodic surges, it could melt patches of the icy surface, releasing bursts of infrared radiation. The synchronicity that could hint at a planetary heartbeat of sorts, with tremors or tidal forces squeezing the core at regular intervals. Imagine squeezing a stress ball rhythmically and watching heat pulse through it. But here's where it gets weirder. Some researchers propose an even wilder idea: a moon. Not just any moon, but one locked in a gravitational tug-of-war with its rogue host. As this hypothetical moon orbits, its gravity might flex the planet's interior, triggering flickers like clockwork. It's a tantalizing thought, because no moon has ever been detected around WISE 0855-0714. If one exists, it's hiding in plain sight. The flicker's infrared signatures add another layer of intrigue. Unlike the broad, messy spectrum of atmospheric flares, these were sharp and distinct, suggesting something more structured, like cracks in the planet's icy shell or vents spewing warm plumes. And then there's the timing. The interval between the two flickers matches no known planetary process, leaving astronomers scratching their heads. Could it be a natural oscillator, like a geyser on a timer? Or something far stranger? One thing's certain. WISE-0855-0714 is no inert ice cube. It's alive with mysteries, pulsing with secrets we've only begun to decode. Up next, a rogue planet humming a tune so strange, it sounds almost musical, another enigma waiting in the cosmic dark. Now, let's turn our attention from the icy flickers of WISE-0855-0714 to a rogue planet with a voice, a deep, resonant hum that defies the silence of space. Enter 2 Mass J1119-1137, a young rogue planet barely 100 million years old, drifting through the cosmos. But this isn't just any wandering world. It sings a low-frequency hum, steady as a heartbeat, pulses from its depths, a sound so precise it nearly mimics musical harmony. What's striking is the hum's regularity. Unlike the chaotic bursts or flickers we've seen from other rogue planets, this signal is eerily consistent, oscillating at a frequency of 162 Hz, a pitch close to the E note below middle C on a piano. It's as if the planet itself is tuned to a cosmic scale. But how does a solitary, starless world produce such a sound? The answer might lie beneath its surface, in places where science is only beginning to venture. One leading theory points to subsurface oceans. Imagine vast, dark seas trapped under miles of ice, their waters churning with currents and tides. On icy moons like Europa or Enceladus, similar oceans generate magnetic fields and seismic activity. For 2 Mass J1119-1137, the hum could be the groan of ice shifting over liquid water, a resonant vibration amplified by the planet's thick crust. Think of it like running a wet finger around the rim of a wineglass. The friction creates a tone. Here, the entire planet might be acting as that glass, vibrating in the cold vacuum of space. Then there's the crystal resonance hypothesis. Some researchers propose that the planet's interior could harbor colossal crystalline structures, perhaps diamonds or other ultra-dense minerals forged under extreme pressure. As these crystals expand and contract with temperature changes, they might vibrate at specific frequencies, turning the planet into a giant celestial tuning fork. It's a phenomenon seen on Earth with quartz crystals in watches, but scaled up to planetary proportions. But there's a twist: the hum isn't perfectly steady. Tiny fluctuations, barely detectable, ripple through the signal. These micro-variations could hint at geological activity, cracks forming in the ice, or even the slow collapse of underground caverns. Alternatively, they might reflect interactions with the interstellar medium, as charged particles buffet the planet's weak magnetic field. What makes 2 Mass J1119-1137's hum so captivating is its musicality. Unlike random cosmic noise, this signal has structure, a quality that blurs the line between natural phenomenon and something almost artistic. Could it be the universe's version of a lullaby, a byproduct of forces we don't yet understand? Or is it a clue to something far grander, a hidden layer of planetary physics waiting to be uncovered? One thing's certain: this rogue planet's song challenges our assumptions about what lonely worlds are capable of. And as we listen, we're reminded that even in the darkest corners of space, there's music, if only we know how to hear it. Next up, a rogue planet that doesn't hum or flicker, but flashes, with a brilliance that left astronomers momentarily blinded. Now, just as we've tuned our ears to the cosmic hum of 2 Mass J1119-1137, prepare to shield your eyes, because our next rogue planet doesn't whisper or sing. It blinds. Meet OGLE-2016-BLG-1928, a mysterious wanderer that lit up the darkness for a fleeting moment, then vanished without a trace. This wasn't just any flicker. In 2016, telescopes caught an optical flash so intense it momentarily outshone nearby stars, a burst of light lasting mere hours before disappearing forever. The brilliance was unprecedented, leaving astronomers scrambling for answers. Was it a trick of the cosmos or something far more profound? The prime suspect. Microlensing, a phenomenon where a rogue planet's gravity bends light from a distant star, acting like a magnifying glass in space. As the planet drifts into alignment, the star's light amplifies, creating a temporary spike in brightness. It's a cosmic illusion, one we've seen before. But here's the catch: OGLE-2016-BLG-1928's flash didn't match the usual microlensing profile. The light curve, the way the brightness spiked and faded, was too sharp, too wrong. Alternative theories quickly emerged. Could this have been an actual eruption on the planet's surface? Imagine a volcanic explosion of unimaginable scale, ripping through an icy crust and ejecting plumes of superheated gas. On Earth, volcanoes like Krakatoa have darkened skies for years, but on a rogue planet with no atmosphere to contain it, such an event might manifest as a single, searing flash. Then there's the impact hypothesis. A rogue planet, untethered from a star, might still collide with asteroids or other debris in the interstellar void. A high-speed strike could vaporize rock and ice in an instant, releasing a burst of light. But for a flash this bright, the impactor would need to be colossal, something the size of a small moon. Statistically, that's staggeringly rare, yet not impossible. But here's what truly chills scientists. OGLE-2016-BLG-1928's flash was a one-time event. No follow-up observations ever detected a repeat. That rarity makes it nearly impossible to study further, leaving us with more questions than answers. If it was microlensing, why the anomaly in the light curve? If it was volcanic or impact-driven, where's the debris? The silence afterward is deafening. This phantom flash lingers in astronomers' minds as a cosmic ghost story, a reminder that some signals defy easy explanation. Was it a fluke of physics or a sign of something stranger lurking in the dark? The mystery endures, challenging us to keep watching the skies. And as we turn the page, our next rogue planet doesn't just vanish. It leaves behind a code, spiraling through the void like a message waiting to be cracked. Now, shifting our gaze from blinding flashes to something far more intricate, we encounter a signal that doesn't just appear, it unfurls. Meet MOA 2011 BLG-262, a rogue planet that didn't simply emit noise, but transmitted a spiral-patterned radio signal so precise it seemed almost designed. This wasn't random static. In 2011, radio telescopes picked up a series of pulses that, when mapped, revealed a stunning spiral structure, like a cosmic fingerprint etched into the fabric of space. The pattern repeated at regular intervals, each iteration maintaining flawless geometric symmetry. Natural cosmic phenomena rarely produce such meticulous shapes, leaving scientists torn between two extraordinary possibilities: an unknown natural process or something far more deliberate. First, let's unravel the natural explanation. Plasma spirals, often seen in the magnetic fields of stars or pulsars, could theoretically form around a rogue planet with a powerful magnetosphere. Charged particles caught in the planet's magnetic grip might spiral along field lines, emitting synchronized radio waves as they move. On Earth, we see hints of this in auroras, where solar wind particles trace magnetic lines in glowing curves. But MOA 2011 BLG-262's signal was orders of magnitude more complex, with a mathematical precision that defies typical plasma behavior. The spiral's tight, logarithmic form, reminiscent of a Fibonacci sequence, suggests a level of organization rarely observed in nature. Then there's the more provocative theory: artificial origin. The signal's repetition and geometric purity echo human-designed radio transmissions, like the Arecibo message sent to the stars in 1974. Could this be a beacon, a deliberate attempt to communicate? The idea isn't as far-fetched as it sounds. Rogue planets, untethered from stellar noise, could serve as ideal platforms for transmitting signals across interstellar space. Without a star's interference, a planet's broadcasts could travel farther and clearer. But here's the catch: no known natural process can entirely explain the signal's precision. and no known technology we possess could generate such a transmission. What's most baffling is the signal's longevity. Unlike the fleeting flash of OGLE-2016-BLG-1928, this spiral pattern persisted for weeks, cycling through its intricate dance before fading into silence. Subsequent observations failed to detect a repeat, adding to its enigma. Was it a one-time astrophysical event or a message meant for a single, fleeting audience? The spiral code of MOA 2011-BLG-262 remains one of the most tantalizing mysteries in the Rogue Planet catalog. It challenges our understanding of natural radio emissions and ignites debates about the boundaries between the cosmic and the constructed. As we move forward, our next signal doesn't just spiral, it whistles, a high-pitched duet from the depths of interstellar space. Now, let's tune our ears to a cosmic mystery that sounds almost musical, a rogue planet emitting not one, but two high-pitched whistles in eerie harmony. Meet WISE 1541-2250, a rogue planet where the silence of deep space is broken by what scientists call whistler waves. But these aren't your average space noises. They're a synchronized duet pulsing through the void with uncanny precision. First, imagine the sound of a radio tuning through static, the sharp, descending whistle you might hear when lightning strikes on Earth. That's a natural whistler wave, created when electromagnetic energy from lightning travels along Earth's magnetic field lines, stretching and distorting into those familiar falling tones. Now take that phenomenon, amplify it by orders of magnitude, and remove the lightning entirely. That's what WISE 1541-2250 is doing, and it's baffling researchers. What makes these signals so strange? For starters, they're paired. Most natural whistlers are singular, random events, but this rogue planet emits two distinct frequencies simultaneously, locked in a tight rhythm. One whistle starts high and dips slightly, while the other holds a steady, piercing note like a cosmic duet between a flute and a theremin. The synchronization suggests a shared origin, yet no known natural process easily explains how a lone planet, without a star or nearby cosmic interactions, could generate such coordinated emissions. One theory points to the planet's magnetic environment. Rogue planets, especially those with strong magnetospheres, could trap charged particles in magnetic loops. If those particles are agitated, say, by interactions with interstellar plasma or internal tidal forces, they might release energy as whistler waves. But here's the twist: Earth's whistlers fade quickly, scattering in the atmosphere. On WISE 1541-2250, the signals are clean and sustained, implying an environment where waves can travel vast distances without distortion. This raises the possibility of a dense, conductive layer in the planet's atmosphere or even subsurface oceans reflecting and amplifying the waves. Then there's the amplification mystery. On Earth, whistlers are faint, detectable only with sensitive equipment. But these rogue planet whistlers are loud, reaching intensities that suggest a powerful energy source. Could the planet's isolation be key? Without a star's interference, its magnetic field might channel energy more efficiently, or perhaps internal heat left over from its formation is fueling persistent electrical activity. Some researchers even speculate about cryovolcanoes, erupting icy plumes that generate static charges, though no direct evidence supports this yet. The duo whistlers of WISE 1541-2250 linger in the data like an unsolved riddle. They blur the line between known physics and something far stranger, reminding us that rogue planets aren't just dark, silent wanderers. They're broadcasting secrets we're only beginning to decipher. And as we move forward, our next signal doesn't whisper or whistle, it warps, bending the very fabric of space-time around it. Now, let's shift our focus from sound to something far more profound, a ripple in the very fabric of space itself. SWEEPS 11, a rogue planet drifting through the cosmos, has done something extraordinary. It's left a fingerprint in the form of gravitational waves. But this isn't just any distortion. It's a ripple that defies expectations, suggesting forces at work we're only beginning to grasp. Gravitational waves are usually the domain of colossal events, black holes colliding, neutron stars merging, or the Big Bang's echoes. So when a lone planet, barely the size of Jupiter, produces a detectable warp in space-time, it stops astronomers in their tracks. Imagine tossing a pebble into a still pond. The ripples are small, fading quickly. Now picture that same pebble creating a wave tall enough to splash over the edges. That's the scale of the anomaly here. SIMP's 11's gravitational ripple shouldn't be this strong, yet there it is, a blip in the data that challenges our understanding of how mass bends space. What could cause such a distortion? One compelling theory involves an unseen companion. Just as the moon tugs on Earth's oceans, creating tides, an invisible object, perhaps a black hole or a dense neutron star, could be orbiting SIMP's 11, warping space around it like a hidden dancer pulling on a cosmic curtain. The ripple's timing hints at a rhythmic interaction, a gravitational tango between the planet and something lurking just beyond our detection. But here's the catch. No such companion has been found, leaving researchers to wonder if the planet is truly alone. Another possibility dives into the bizarre. Space-time itself might be behaving differently around SIMP's 11. In regions of extreme gravity, like near a black hole, space can stretch and twist like taffy. Could this rogue planet be passing through a pre-existing warp in the universe, amplifying its own gravitational signal? It's a fringe idea, but not impossible. Think of it as walking on a trampoline. Your weight alone creates a dip, but if the fabric is already bent by someone else's jump, your impact becomes far more dramatic. Then there's the wild card, exotic matter. Some theories suggest that certain types of undiscovered particles or dark matter could cluster around rogue planets, adding unseen mass that magnifies their gravitational influence. It's like stuffing a pillow with invisible weights. The fluff looks normal, but the scale tells a different story. The gravity ripple of SIMP's 11 is a puzzle wrapped in the enigma of rogue planets. It forces us to question what we know about mass, space, and the hidden relationships between cosmic objects. And as we turn our attention to the next signal, prepare for a shift from the invisible to the unmistakably vivid, a beacon of light that flickers through the cosmos in a spectrum of colors no one anticipated. Now, let's step into the realm of light, where the cosmic mystery takes on a dazzling, almost artistic form. Meet OGLE-2016-BLG-1927, 49 plus 271,757, 31, a rogue planet that doesn't just drift silently through the void. Instead, it broadcasts a signal unlike any other, a flickering, color-shifting beacon that pulses across the spectrum like a celestial mood ring. One moment it's a deep crimson, the next an eerie cerulean, cycling through hues faster than any known natural phenomenon. This chromatic display has astronomers scratching their heads. Is it a quirk of physics or something far more deliberate? First, let's tackle the natural explanations. Light behaves strangely when passing through extreme atmospheres, and rogue planets, untethered from stars, can develop wild weather patterns. Imagine a prism the size of a planet, where swirling layers of exotic gases like methane, ammonia, or even metallic hydrogen bend and scatter light into shifting colors. On Earth, we see a simpler version of this during sunsets, when the atmosphere filters sunlight into reds and oranges. But on OGLE-2016-0947, 49 plus 271,757, 31, the effect could be amplified by hurricane-force winds or towering crystal clouds, acting like a disco ball for the cosmos. Some theorists suggest the planet's rapid rotation might be key, with different atmospheric layers refracting light at varying speeds to create this kaleidoscopic show. Yet there's a wrinkle in this theory: the pattern. Unlike random atmospheric scattering, the color shifts follow a precise, repeating sequence almost like a code. This has led to whispers of another possibility: intentional signaling. If an advanced civilization existed on or around this rogue planet, they might use such a beacon as a lighthouse across interstellar space. The colors could correspond to specific information coordinates, warnings, or even an attempt at communication. Skeptics argue that natural processes can mimic patterns, pointing to pulsars, which emit rhythmic radio waves without any intelligent design. But pulsars don't change colors, and that's what makes this signal so tantalizing. Then there's the middle ground: exotic physics. Rogue planets often traverse regions of space rich in dark matter or plasma currents. Could interactions with these invisible forces twist light into chromatic patterns? Picture dipping a glow stick into different liquids. Each one alters its hue. If so, J030947, 49 plus 271,757, 31 is plowing through pockets of ionized gas or magnetic fields. Its light might be painted by the cosmos itself. What's undeniable is that this chromatic beacon challenges our assumptions. Natural or not, it forces us to reconsider how light can be manipulated on a planetary scale. And as we move to the next signal, prepare for a different kind of mystery, one that doesn't flicker or shine, but instead leaves an unsettling silence in its wake. But now, let's shift to something far more unsettling, a signal that defies expectations, not with light or sound, but with its eerie absence of both. Meet CFBDSIR, a rogue planet that emitted one of the most powerful electromagnetic surges ever recorded, yet it did so in complete silence. This wasn't the crackling roar of a solar flare or the hiss of radio static. It was a burst of energy so intense it should have screamed across the cosmos, but instead it arrived as a ghostly whisper, leaving scientists baffled by its paradox. To understand why this silent scream is so unusual, let's compare it to something familiar: solar flares. When our sun erupts, it unleashes storms of charged particles and electromagnetic radiation, often accompanied by bursts of radio noise that can disrupt satellites and auroras that paint the sky. These flares are anything but silent. They're the sun's way of shouting its activity to the universe. But CFBDS0059 surge carried none of that auditory footprint. It was like a flashbang detonating in a vacuum, all light, no sound. So what could cause such a bizarre phenomenon? One leading theory points to the collapse of a rogue planet's magnetosphere. Unlike Earth, which is shielded by a steady magnetic field generated by its molten core, rogue planets lack the consistent heat of a nearby star. Over time, their cores may cool and solidify, causing their magnetic fields to weaken and eventually snap like an overstretched rubber band. When this happens, the planet's magnetosphere, the protective bubble of charged particles around it, could implode in a catastrophic event. The result: a massive release of pent-up electromagnetic energy, but without the charged particles or plasma waves that typically create detectable noise. Imagine a dam breaking underwater. The force is colossal, but the turbulence is muted compared to a collapse in open air. Similarly, CFBDS0059 surge might have been silent because it occurred in an environment stripped of the ionized gas or plasma needed to translate that energy into sound like waves. Alternatively, the signal could have been so high frequency that our instruments simply couldn't pick up its voice, rendering it mute to our ears. There's another spine-tingling possibility. What if something absorbed the sound? Rogue planets often wander through dense clouds of interstellar dust or dark matter. If CFBDS0059 surge passed through such a veil, these particles might have scattered or dampened the audible components of the signal, leaving only the silent electromagnetic pulse behind. It's like hearing thunder through thick fog. The lightning's flash remains, but the boom vanishes. What makes this signal so haunting isn't just its silence, it's the sheer power behind it. This wasn't a flicker or a flicker. It was a seismic release of energy, the kind that could rewrite our understanding of how planetary systems die. And as we turn to the next mystery, be prepared for a signal that doesn't just challenge our ears, but our very grasp of mathematics itself. Now, let's journey into a signal that doesn't just defy expectations, it dances to the rhythm of nature's most elegant code. From the depths of interstellar space, WISE 1828+2650 sent a signal that wasn't random noise or chaotic static. It pulsed in a pattern so precise, so perfectly ordered, it mirrored the Fibonacci sequence, the same mathematical spiral found in sunflower seeds, hurricanes, and even the curve of galaxies. At first glance, a Fibonacci signal from a rogue planet seems impossible. This isn't just a series of numbers, it's a fingerprint of growth, a pattern where each step builds on the one before it, 1, 1, 2, 3, 5, 8, and so on. In nature, it emerges from systems where efficiency and adaptation rule. But in the vacuum of space, on a world without a star, that's where the mystery begins. Could this be a cosmic coincidence? Chaos theory suggests that even in turbulent systems, fleeting moments of order can arise. Think of a whirlpool forming in a rushing river, a temporary spiral amid the churn. Some scientists argue WISE 1828+2650 signal might be a similar anomaly, a rare alignment of atmospheric currents or magnetic vibrations that briefly mimic the Fibonacci sequence. But here's the problem: this signal wasn't a fleeting blip. It repeated for hours with near-perfect adherence to the pattern. That's like flipping a coin 100 times and getting heads every single time possible, but statistically staggering. Then there's the more tantalizing angle. What if this isn't chaos at all, but precision engineered by something or someone? The Fibonacci sequence is famously tied to efficiency. It's how plants maximize sunlight and how shells strengthen without excess weight. If a signal follows this pattern intentionally, it could be a beacon designed for clarity, cutting through cosmic noise like a laser through fog. But before we leap to extraterrestrial architects, let's consider another twist. Rogue planets might harbor hidden forces we've yet to understand. Subsurface oceans, for example, could slosh in rhythmic tides beneath icy crusts, their movements sculpted by unseen moons. If those tides interact with the planet's magnetic field, could they generate resonant frequencies that echo Fibonacci's math? Or perhaps crystalline structures in the planet's mantle vibrate at harmonic intervals, like the strings of a piano tuned to nature's scale. And then there's the darkest horse of all, quantum vibrations. At microscopic scales, particles can entangle in ways that defy classical physics, creating order from apparent randomness. If quantum processes on WISE 1828+2650 scaled up to planetary levels, a wild idea, but not impossible, they might produce signals with mathematical purity. What leaves scientists sleepless isn't just the how of this signal, but the why. Mathematics is the universe's language, but it rarely speaks so clearly. As we turn to the next enigma, prepare for a signal that doesn't just repeat, it returns from the dead, hours after it should have faded into silence. Now, imagine a signal that doesn't just vanish into the void, but lingers like a whisper bouncing between canyon walls long after the speaker has gone. This is what astronomers witnessed with rogue planet 2 mass J2208+2921. Its signal didn't fade away as expected. Instead, it returned hours later, clear and unmistakable, as if the cosmos itself had pressed pause and then replayed the moment. Time-delayed echoes in space are rare but not unheard of. Normally, they occur when signals scatter off interstellar dust or plasma, taking slightly different paths to reach us, a phenomenon called multipath scattering. Think of it like shouting into a room filled with mirrors. Your voice hits some surfaces directly, while other reflections take longer, arriving as faint, staggered repeats. But 2 mass J2208+2921's echo was different. The delay wasn't milliseconds or even minutes, it was hours. That's like hearing your shout echo back an entire day later, long after you've left the room. One explanation points to an extreme version of multipath scattering. If this rogue planet's signal passed through an unusually dense pocket of interstellar medium, perhaps a drifting molecular cloud or a rogue nebula, it could have been bent and slowed, creating a cosmic hall of mirrors. But here's the catch: for a delay that long, the scattering material would need to be both incredibly thick and improbably positioned. It's like threading a needle across light years. Another theory suggests the signal might have ricocheted off an unseen object, a hidden moon, a debris field, or even a previously unknown planetary companion. If the signal struck a highly reflective surface, say, an icy moon with a mirror-smooth crust, it could have bounced back toward us with minimal distortion. Yet even this idea struggles to explain the echo's clarity. Most natural reflectors in space are rough or irregular, which would scramble the signal like sunlight glinting off choppy water. Then there's the spine-tingling possibility. What if the delay wasn't caused by something in space, but by spacetime itself? Einstein's theory of relativity tells us massive objects warp the fabric of reality, slowing time in their gravity wells. If 2 mass J2208 plus 2921 passed near a black hole or another dense object, its signal could have been stretched like taffy, arriving in disjointed fragments. But no such object was detected along the signal's path, leaving this idea in the realm of speculation. The most unsettling quality of this echo isn't just its lateness, it's its precision. The repeated signal wasn't garbled or weakened. It was nearly identical to the original, as if the planet had recorded its own emission and played it back on a timer. That level of preservation defies most natural explanations, hinting at phenomena we've yet to uncover. As we move forward, another rogue planet awaits, one whose signals didn't just repeat, but arrived in perfect sync, as if orchestrated by an invisible hand. The universe, it seems, still holds its most puzzling rhythms close to the chest. Now, let's shift our attention to a cosmic duet, one that doesn't sing in harmony but groans in deep, resonant frequencies. Meet WISE 0410 plus 1502, a rogue planet that didn't just emit one mysterious signal, it produced two, intertwined in a way that left scientists scratching their heads. These weren't the usual radio bursts or flickers of light. These were low, rumbling vibrations, like the creaking of an old wooden ship adrift in an endless sea. The first thing that stood out was their depth. These groans registered at frequencies so low they bordered on infrasound, the kind of vibrations you feel more than hear. On Earth, infrasound is often associated with natural phenomena, earthquakes, volcanic activity, even the movement of glaciers, so one immediate theory pointed to planetary quakes. Imagine this rogue planet untethered from any star, its interior cooling and contracting over billions of years. As it shrinks, its crust could fracture, sending seismic shudders rippling through its frozen mantle. But here's the twist: these groans weren't random. They came in pairs, separated by a precise interval, almost as if the planet was ticking like a metronome. That rhythmic timing led researchers to another possibility: tidal forces. On Earth, our moon's gravity tugs at the oceans, creating the rise and fall of tides. But what if WISE 0410 plus 1502 wasn't alone? What if it had a hidden companion, another rogue planet or a massive moon locked in a gravitational dance? The strain of that relationship could flex the planet's core, generating those twin groans with each gravitational squeeze. It's a compelling idea, but there's a catch. No such companion has been detected, and the odds of two rogue planets orbiting each other in the vast emptiness of interstellar space are astronomically low. Then there's the eerie elegance of the signals themselves. Unlike the chaotic rumble of an earthquake, these groans were eerily pure, almost musical. Some scientists have suggested they could be the result of resonant vibrations within the planet's structure. Think of a bell ringing after being struck. If Y0410 plus 1502 has a subsurface ocean, for example, the sloshing of liquid beneath an icy shell could create standing waves amplifying certain frequencies. Or perhaps its core is layered with exotic materials like metallic hydrogen, vibrating in ways we've never observed before. But the most tantalizing theory leans into the unknown. What if these groans aren't geological at all? What if they're the product of something even more extraordinary, like the planet's magnetic field interacting with the interstellar medium? Rogue planets devoid of a star's energizing light often have weak magnetic fields. But if Y0410 plus 1502's field were unusually strong, it could generate low-frequency waves as it plows through cosmic dust and gas like a ship's bow cutting through waves. As we grapple with these possibilities, one thing becomes clear. Y0410 plus 1502's groans are more than just noise. They're a cryptic message, one that challenges our understanding of how solitary worlds behave in the darkness. And with that, we turn to an even stranger phenomenon, a rogue planet that didn't just groan or flicker, but seemed to rain particles straight from the subatomic realm. Now, let's step into a realm where the invisible becomes the extraordinary. Deep in the cosmic void, OGLE-2016-BLG-1928 didn't just whisper or groan, it unleashed something far more elusive, a shower of neutrinos. These ghostly particles, so tiny they can pass through entire planets without a trace, are rarely detected from rogue worlds. Yet here they were, a sudden burst captured by sensitive observatories, defying expectations and leaving scientists with a puzzle wrapped in mystery. Neutrinos are nature's most aloof particles. Born from nuclear reactions, they zip through the universe at nearly the speed of light, barely interacting with matter. On Earth, they're produced in abundance by the sun or in particle accelerators, but detecting them requires massive, painstakingly calibrated instruments buried underground or submerged in ice. So when a rogue planet, a world without a star, emits them, it's like hearing a silent scream in a vacuum. How does a cold, isolated object like OGLE-2012-BLG-1928 generate such high-energy particles? One theory points to the planet's interior. While rogue planets lack the fusion engines of stars, they might still harbor radioactive elements like uranium or thorium in their cores. As these elements decay, they could produce neutrinos in sporadic bursts. Imagine a slow, subterranean furnace, its heat not from fire but from radioactivity, occasionally belching out these ethereal particles. But there's a problem. The neutrinos detected from OGLE-2012-BLG-1928 were far more energetic than standard radioactive decay should produce. Another possibility involves cosmic collisions. Rogue planets drifting untethered through space might occasionally plow into dense clouds of interstellar gas or dust. The sheer force of these impacts could generate shockwaves powerful enough to rip atoms apart, creating neutrinos as a byproduct. Picture a snowball smashing into a wall at hypersonic speeds, except here, the snowball is a planet and the wall is a cosmic obstacle. Yet, this explanation also falls short. The neutrino burst from OGLE-2012-BLG-1928 was too prolonged, too steady to stem from a single catastrophic event. Then there's the wildcard, primordial black holes. Some theorists suggest that tiny, ancient black holes, remnants of the early universe, could be lurking within rogue planets. As these black holes evaporate over eons, they might release energy in the form of neutrinos. It's a fringe idea, but not impossible. After all, rogue planets are among the oldest objects in the galaxy, and if any harbor such exotic tenants, their neutrino signatures would be unlike anything we've seen. Detecting these signals, however, is a feat of patience and precision. Neutrino observatories like IceCube in Antarctica or Super Kamiok and in Japan are designed to catch the fleeting flashes of light produced when a neutrino against all odds collides with an atom. But rogue planets are distant and their neutrino emissions faint, distinguishing a signal from OGLE-2016-BLG-1928 amid the constant background chatter of cosmic rays and solar neutrinos is like picking out a single piano note in a thunderstorm. What makes this burst even more intriguing is its timing. Unlike the rhythmic groans of WISE 0410 plus 1502, OGLE 2012 BLG 1323 neutrinos arrived in a single, intense cascade. Was this a one-time event, the last gasp of a dying process inside the planet? Or is it part of a cycle we've yet to uncover? Without more data, the answer remains as elusive as the neutrinos themselves. As we piece together these clues, one thing is certain. OGLE 2012 BLG 1323 has opened a new window into the hidden lives of rogue planets. These worlds, once thought to be dark and inert, are proving to be anything but. And with that, we turn our gaze to another enigma, a signal so polarized, so intense it seems to scream across the cosmos. Leaving behind the ghostly whispers of neutrinos, we now encounter a signal that doesn't just speak, it shrieks. WISE 1217 plus 1626 doesn't emit ordinary radio waves. What telescopes captured from this rogue planet was something far more peculiar. A polarized scream, a blast of radio energy twisted into a tight, spiraling pattern. This isn't just noise, it's a signal with a fingerprint, a clue written in the language of magnetism and motion. Polarized radio waves are rare in the cosmos. Unlike the chaotic static we often pick up, these waves vibrate in a single, disciplined plane, as if they've been combed straight by an invisible force. On Earth, we see this effect in sunglasses blocking glare, or in the way certain crystals filter light. But in space, polarization usually points to one thing: extreme magnetic fields. And WISE 1217 plus 1626 seems to be drowning in them. Imagine the magnetic field of Jupiter, already thousands of times stronger than Earth's. Now amplify that by a factor of 10 or even 100. That's the kind of environment we're dealing with here. Magnetic fields this intense don't just bend radio waves, they wrench them into alignment like iron filings snapped to attention by a magnet. But how does a rogue planet, cold and starless, generate such a monstrous magnetic field? One explanation lies in its interior. Some rogue planets, especially those with metallic hydrogen cores, could act like colossal dynamos. As the planet rotates, currents of electrically conductive material swirl in its depths, generating a magnetic field that spills into space. If WISE 1217 plus 1626 spins rapidly, think once every few hours, it might be cranking out a magnetic monster capable of polarizing its radio emissions. Then there's the jet hypothesis. Picture a geyser, but instead of water, it's spewing charged particles at near light speed. These jets, often seen around black holes or neutron stars, can also form around planets with strong magnetic fields and volatile atmospheres. As particles spiral along magnetic field lines, they emit polarized radio waves, creating a scream that cuts through the interstellar medium like a lighthouse beam. If WISE 1217 plus 1626 has such jets, they'd be the first detected from a rogue planet, rewriting our understanding of these nomadic worlds. But here's the twist: the polarization isn't constant. It flickers, shifting angle over hours or days. That rules out static structures like a rigid magnetic field. Instead, it suggests something dynamic, perhaps storms in the planet's atmosphere, where pockets of ionized gas twist magnetic lines into knots. Or maybe the planet is tumbling, its magnetic poles wobbling like a spinning top losing momentum. Either way, this variability makes the signal even harder to decode. Detecting this scream was no small feat. Radio telescopes had to sift through a cacophony of cosmic static, isolating the polarized signal like picking a single voice from a crowded room. And even then, the data was messy, requiring advanced algorithms to untangle the polarization's precise angle and strength. It's a testament to how far our technology has come and how much further we have to go. What's truly baffling is the signal's intensity. Rogue planets aren't supposed to be this loud. Most are frigid, their atmospheres too thin to support the energetic processes needed for powerful radio emissions. Yet WISE 1217 plus 1626 defies that expectation, screaming into the void with the vigor of a pulsar. Is it drawing energy from some hidden source? Or are we seeing the death throes of a magnetic field collapsing under its own weight? As we wrestle with these questions, one thing is clear: polarized signals like this are more than curiosities. They're probes letting us peer into the invisible forces shaping rogue planets. And with that, we turn to another mystery, a signal that doesn't just communicate, but seems to encode a message. Now, shifting our gaze to a signal that seems almost intentional, we arrive at WISE 1711 plus 3500. Unlike the chaotic screams or ghostly hums we've encountered, this rogue planet emits something eerily familiar, a sequence of dots and dashes that uncannily resemble Morse code. It's a pattern that immediately grabs attention, not just for its rhythm, but for the unsettling question it raises. Could this be a natural phenomenon, or is something, or someone trying to communicate? First, let's break down what makes this signal so unusual. The pulses from WISE 1711 plus 3500 arrive in bursts, each lasting milliseconds with precise intervals between them. Some sequences repeat like a looping message, while others appear randomized. To the untrained ear, it might sound like static, but when mapped visually, the pattern evokes the structured cadence of human-made code. The resemblance is striking enough that researchers initially double-checked their equipment, ruling out terrestrial interference or satellite artifacts. One compelling natural explanation ties the signal to pulsar-like behavior. Pulsars, the rapidly spinning cores of dead stars, emit beams of radiation that sweep across space like lighthouse beams, creating regular pulses. Some rogue planets, particularly those with highly magnetized cores, could theoretically produce similar emissions. If WISE 1711 plus 3500 has a dense metallic interior and spins rapidly, its magnetic field might channel charged particles into beams, resulting in periodic bursts. The dots could be short, intense releases of energy, while dashes might stem from slightly longer ejections. But there's a catch. Pulsars typically exhibit near-perfect regularity, their pulses predictable down to microseconds. This signal, however, drifts. The intervals between bursts stretch and compress subtly, as if the source is slowing down or speeding up. That's rare for a celestial clockwork mechanism, leading some to propose alternatives like planetary aftershocks. Imagine quakes rippling through the planet's crust, fracturing magnetic field lines and triggering sporadic bursts. Or consider the possibility of a hidden companion, a moon or another rogue planet, whose gravitational tugs disrupt the emission rhythm. Then, of course, there's the elephant in the room, the extraterrestrial hypothesis. The signal's quasi-coded structure inevitably sparks speculation about intelligent origins. Could this be an attempt at contact or perhaps a beacon? Scientists approach this idea with caution, emphasizing that nature often mimics order without intent. For example, Jupiter's moon Io generates radio emissions that sound like space-based whistlers, and nobody claims aliens are responsible. Still, the Morse-like quality of WISE 1711 plus 3500 signal is undeniably intriguing, prompting organizations like the SETI Institute to take a closer look. To maintain perspective, let's revisit what we know. The signal's power is modest, nowhere near the strength you'd expect from a deliberate broadcast. Its frequency also drifts across the radio spectrum, a trait more consistent with natural plasma interactions than engineered transmission. and crucially, no repeating message deciphers into anything meaningful using human linguistic or mathematical frameworks. It's a cosmic Rorschach test. We see patterns because we're wired to, not because they're inherently there, yet the mystery lingers. If this is purely natural, why does it stand out among the thousands of rogue planet signals we've catalogued? Could it be a rare glimpse of a previously undocumented phenomenon, like a planetary scale maser, a naturally occurring microwave amplifier, or does it hint at processes we've yet to theorize, lurking in the uncharted physics of rogue worlds? As we ponder these questions, one thing becomes clear. Signals like this blur the line between the known and the unknown. They challenge us to keep searching, testing, and above all, remaining open to the possibility that the universe's strangest answers are still waiting to be decoded. And with that, we turn to a signal that defies visibility, a glow that hides in plain sight. Now, let's step into the shadows of the cosmos, where light itself seems to play tricks on us. WISE 1741 + 2553 emits a glow that's as elusive as it is enigmatic, visible only in the infrared spectrum, completely invisible to other forms of detection. It's like a cosmic whisper, felt but not seen, leaving scientists scrambling to explain why this rogue planet refuses to reveal itself in any other light. What makes this infrared glow so baffling? For starters, most celestial objects emit radiation across multiple wavelengths. Stars blaze in visible light, pulsars scream in radio waves, and even cold rogue planets typically leave faint traces in microwave or submillimeter spectra. But WISE 1741 + 2553 is an outlier. Its thermal signature is strong enough to be picked up by infrared telescopes, yet it vanishes when astronomers point other instruments its way. This selective visibility suggests something unusual is either absorbing or scattering all other forms of radiation, leaving only infrared to escape. One leading theory points to exotic atmospheric chemistry. Imagine a planet shrouded in a haze of heavy molecules, complex hydrocarbons, or even metallic vapors that act like a one-way filter. These particles could absorb higher energy wavelengths like visible or ultraviolet light, while allowing longer infrared waves to pass through. On Earth, we see a milder version of this phenomenon with greenhouse gases trapping heat. But on WISE 1741 + 2553, the effect would need to be extreme, perhaps involving compounds we've never encountered. Lab experiments with titanium oxide and silicate clouds have shown similar selective absorption, but nothing as absolute as what this rogue planet exhibits. Then there's the more speculative angle, exotic matter. Some researchers float the idea of particles beyond the standard model, like actions or dark photons, interacting uniquely with this planet's environment. These theoretical particles could, in principle, convert other forms of radiation into infrared or scatter them into undetectable directions. It's a long shot, but rogue planets untethered from stars might be ideal laboratories for such physics. Without the interference of a host star's light, subtle anomalies become easier to spot. Of course, no discussion of an invisible object would be complete without a nod to stealth technology theories. While firmly in the realm of science fiction, the idea that an advanced civilization could cloak a planet isn't entirely absurd from a physics standpoint. Directed energy systems or metamaterials, engineered substances designed to bend light could, in theory, mask a world's emissions. But before we jump to interstellar intrigue, let's remember nature's knack for stranger-than-fiction solutions. The galaxy is full of natural cloaking devices, dust clouds, plasma fields, and gravitational lenses that distort or hide objects without any intelligent intervention. What's perhaps most compelling about this signal is the way it challenges our assumptions about detection. Modern astronomy relies on multi-wavelength observations to piece together cosmic puzzles. When an object defies that approach, it forces us to reconsider what might be lurking in the data, or what we might be missing entirely. Could there be a population of invisible rogue planets detectable only under specific conditions? If so, our current surveys might be seeing just a fraction of the wanderers out there. As we move forward, WISE 1741 plus 2553 stands as a reminder that the universe still holds cards close to its chest. Whether the answer lies in unknown chemistry, new physics, or simply a quirk of nature, this infrared ghost invites us to look deeper and to question what else might be hiding in plain sight. And with that, we pivot to a signal that defies the very laws of quantum certainty. Now, let's venture into the quantum realm where the rules we think we know begin to unravel. PSO J077.4243 plus 12.0378 has sent scientists into a frenzy with a signal that seems to defy one of physics' most sacred laws, Heisenberg's uncertainty principle. Normally, this principle states that you can't precisely measure both a particle's position and its momentum at the same time. The more you pin down one, the fuzzier the other becomes. But this rogue planet signal, it appears to do the impossible, offering measurements so precise they shouldn't exist. So how could a signal violate such a fundamental rule? One camp argues for quantum entanglement, a phenomenon where particles become linked, sharing properties instantaneously no matter how far apart they are. If entangled particles on PSO J077.4243 plus 12.0378 were somehow influencing the signal, it might create the illusion of bypassing uncertainty. Imagine two dice that always roll matching numbers, no matter how far apart they are. That's entanglement in action, but here's the catch. Entanglement usually doesn't violate uncertainty. It just shifts the uncertainty elsewhere. For this signal to truly break the rules, we'd need entanglement on a scale or in a form we've never seen before. Then there's the skeptic's take, instrument error. Quantum measurements are notoriously finicky, and even tiny disturbances, cosmic rays, thermal noise, or calibration glitches can skew results. Maybe what we're seeing isn't a violation of physics, but a quirk of the tools we're using. After all, rogue planets drift through chaotic environments filled with magnetic fields and interstellar dust, any of which could muddy the data. But here's the twist: multiple telescopes, each with different systems, have detected this signal. For it to be an error, the same glitch would need to occur across unrelated instruments, a cosmic coincidence that feels just as unlikely as the signal itself. For the sci-fi fans, though, the real thrill lies in the wilder possibilities. Could this signal be evidence of quantum technology beyond our understanding? Some theorists play with the idea of quantum locks, advanced systems that stabilize particles in ways nature ordinarily forbids. It's a stretch, but not entirely impossible. After all, rogue planets free from stellar interference might be ideal testing grounds for civilizations experimenting with quantum control. Or perhaps the planet's extreme environment, intense magnetic fields, or exotic matter creates natural conditions that bend quantum rules. What makes this signal so tantalizing is how it blurs the line between known physics and the unexplored. If it's real, it could rewrite textbooks, revealing gaps in our understanding of quantum mechanics. If it's noise, it's a reminder of how delicate our hunt for cosmic truths can be. Either way, PSO J077.4243 plus 12.0378 has handed us a puzzle that's as much about the limits of our knowledge as it is about the signal itself. And with that, we turn to a shimmering mystery, one that suggests a rogue planet might be raining diamonds from its skies. Now, let's trade quantum enigmas for something equally dazzling yet strangely poetic: the diamond dust echo of WISE 1405 plus 5534. Picture this, a signal that doesn't just carry data but seems to shimmer, as if countless tiny mirrors are scattering its waves. What scientists detected wasn't just noise, it was a rhythmic pattern suggesting reflections off crystalline structures, something rigid, orderly, and breathtakingly precise. So where does this ethereal echo come from? One leading theory points to diamond rain, a phenomenon that sounds like science fiction but is very real under extreme pressures. Deep within gas giants like Jupiter and Saturn, carbon atoms are crushed into diamonds, falling like glittering hail through layers of metallic hydrogen. Now imagine a rogue planet untethered from any star with even colder, denser interiors. The conditions there could forge diamonds on a scale we've never seen, and if those diamonds are vibrating or colliding in the planet's depths, they might just produce the crystalline echoes we're detecting. It's like dropping a handful of diamonds onto a glass floor, each impact ringing out in perfect mathematical harmony. But diamonds aren't the only suspects. Another camp argues for vibrations within an icy mantle. Rogue planets, especially those ejected early from their star systems, could retain thick shells of water ice laced with minerals. As temperatures and pressures shift, these icy layers might fracture and resonate, sending out signals that mimic crystalline reflections. Think of it like tapping a glacier with a hammer. The sound waves bounce through the ice, revealing hidden structures beneath. Some researchers even suggest clathrate hydrates, ice-like compounds that trap gases in cage-like formations, could be the source, creating echoes with a unique, almost musical quality. Here's where it gets even stranger. The signal's precision hints at something more than random vibrations. The echoes arrive in patterns so regular they seem engineered. Could natural processes alone explain this, or is there a slim chance we're glimpsing something artificial? While it's a far-fetched idea, a few theorists speculate about crystalline technology, advanced structures designed to resonate at specific frequencies for communication or energy storage. It's a stretch, but rogue planets with their isolated environments might just be the perfect place to test such experiments, far from prying eyes. What makes WISE 1405 plus 5534 so captivating isn't just the science, it's the imagery it conjures. A world where diamonds fall like rain, where ice sings under pressure, or where something even more extraordinary hums beneath the surface. Whether natural or not, this signal reminds us that the universe is richer, stranger, and more inventive than we could ever imagine. And with that, we turn to a signal that plays by its own rules, one that brightens when others fade, defying every expectation. Now, let's step into the realm of cosmic contradictions with the anti-correlation flash of WISE 0458 plus 6434. While most signals in space follow predictable patterns, brightening and fading in sync with known phenomena, this rogue planet's behavior flips the script entirely. Imagine a symphony where one instrument plays softer as the others grow louder, defying the conductor's cues. That's precisely what astronomers observed here, a signal that dims precisely when others in its vicinity intensify, as if it's dancing to an unseen rhythm. So what could cause such bizarre behavior? Mainstream theories point to shadow matter, a hypothetical form of matter that doesn't interact with light or ordinary matter except through gravity. If WISE 0458 plus 6434 harbors pockets of this elusive substance, its gravitational pull might temporarily obscure the planet's emissions when surrounding cosmic activity peaks. Think of it like a shadow passing over a flashlight's beam, but on a planetary scale. Some models suggest rogue planets untethered from stars could accumulate shadow matter over eons, making them ideal laboratories for detecting these faint, ghostly interactions. But shadow matter isn't the only wild card on the table. A handful of physicists entertain an even more speculative idea: interdimensional leakage. In theories like string theory, our universe could be just one membrane floating in a higher dimensional space. If this rogue planet signal is brushing against another dimension, its light might leak away when neighboring signals surge, creating the observed anti-correlation. Picture a sieve straining water. The harder you pour, the more escapes through unseen gaps. While this idea ventures into science fiction territory, it's a tantalizing reminder of how much we still don't understand about the fabric of reality. Now, let's ground this in observable science. One plausible natural explanation involves magnetic field anomalies. Rogue planets often boast extreme magnetospheres, and if WISE 0458 plus 6434's field fluctuates inversely to nearby cosmic rays or stellar winds, it could suppress emissions during external bursts. Imagine a noise-cancelling headset for light. The louder the environment, the more the planet's signal gets muted. This would require a magnetic setup unlike anything we've seen, but rogue planets are nothing if not outliers. Here's where the mystery deepens. The signal's anti-correlation isn't just random. It follows a precise mathematical relationship with its surroundings, almost like a coded response. This has led a minority of researchers to propose an even more radical notion: intentional modulation. Could something or someone be using these flashes as a form of cosmic semaphore, dimming signals to convey information against the backdrop of space's natural noise? It's a fringe hypothesis, but the precision is hard to ignore. What makes WISE 0458 plus 6434 so fascinating isn't just the what, but the why. Whether it's shadow matter, hidden dimensions, or magnetic oddities, this rogue planet challenges us to rethink the rules. And as we turn to our final signal, one that vanishes without a trace, remember, the universe's greatest puzzles often lie in the details we can't yet explain. Just when we think we've seen it all, the cosmos throws us yet another curveball: the vanishing signal of WISE 1952 plus 7240. Picture this: astronomers are tracking a steady, enigmatic emission from this rogue planet, taking notes, running calculations, and then, without warning, it simply winks out of existence. No gradual fade, no disturbance in nearby space, just gone. It's like watching a candle flame snuffed out by an invisible hand, leaving researchers scrambling for answers. So, what could explain such a sudden disappearance? The first and most mundane possibility is equipment failure. Space telescopes and radio antennas aren't infallible. Glitches happen. Maybe a software bug misinterpreted the data, or a cosmic ray zapped the detector at the worst possible moment. But here's the catch: multiple observatories operating independently across the globe all reported the same thing. The signal vanished simultaneously for each of them. That's like every radio in your house losing the same station at the exact same second. Unlikely, absolutely, impossible, not quite. This brings us to a far more intriguing explanation. What if WISE 1952 plus 7240 didn't just stop emitting? What if it somehow cloaked itself? In recent years, scientists have theorized that rogue planets, especially those with extreme atmospheric conditions, might naturally develop transient stealth modes. Imagine a planet shrouded in a dense layer of ionized gas or exotic particles that, under the right conditions, could bend light or absorb specific wavelengths, effectively rendering its signals invisible to our instruments. It's not science fiction. Certain metamaterials on Earth can already manipulate light in similar ways, albeit on a much smaller scale. But let's push the envelope further. Could this vanishing act be intentional? Before you dismiss the idea, consider this: the signal's abrupt cutoff aligned with no known natural phenomena. No solar flares, no passing asteroids, just silence. Some researchers argue that advanced civilizations, if they exist, might use such disappearances as a deliberate tactic, perhaps to avoid detection or to conserve energy. It's a controversial take, but the sheer precision of the signal's disappearance fuels speculation. After all, nature rarely operates with such surgical timing. Here's where things get spine-tingling. Months after the signal vanished, a team in Chile picked up an ultra-faint echo, a ghostly remnant of the original emission from the same coordinates. Lasting mere milliseconds, it defied all attempts at replication. Was it a fluke, a delayed reflection from interstellar dust, or something more deliberate, like a cosmic farewell before the planet slipped fully into the shadows? As we close this chapter on rogue planets and their unexplained signals, remember, WISE 1952 plus 7240 didn't just challenge our understanding, it flat out defied it. Whether through natural stealth, technological prowess, or sheer cosmic irony, this rogue planet's final act was to remind us that the universe holds its secrets close. And perhaps that's the most thrilling mystery of all. What do you think happened to the signal? Drop your theories in the comments below, and don't forget to subscribe for more deep dives into the universe's greatest enigmas. The cosmos is full of stories waiting to be told, and we're just getting started. Hit that notification bell so you never miss an update. Until next time, keep looking up. Now, stepping back to take in the bigger picture, let's unpack what these 25 enigmatic signals mean for our understanding of rogue planets and the universe itself. The truth is, every one of these transmissions has sent shockwaves through the scientific community, forcing us to rethink some of the most fundamental assumptions about planetary behavior. Take rogue planet atmospheres, for instance. Conventional wisdom suggests these drifting worlds, untethered from stars, should be frozen wastelands, their atmospheres collapsed into icy shells without a sun's warmth. But signals like the harmonic hum of 2-mass J1119-1137, with its eerie musical resonance, hint at dynamic atmospheres churning with energy. Could subsurface oceans or geothermal vents be generating enough heat to sustain volatile gases? Or perhaps unknown chemical reactions fueled by cosmic rays or interstellar radiation are at play? Either way, these findings suggest rogue planets might be far more geologically active and chemically complex than we ever imagined. Then there's the puzzle of magnetic fields. The polarized scream of WISE 1217 plus 1626, for example, points to magnetic forces so intense they twist radio emissions into corkscrew patterns. That's a problem because, according to current models, rogue planets shouldn't have strong magnetic fields at all. Without a molten metal core stirred by tidal forces from a nearby star, what's generating these colossal magnetic storms? Some theorists propose exotic states of matter, like metallic hydrogen, could be lurking beneath these planets' surfaces, creating dynamos unlike anything in our solar system. Others wonder if interstellar plasma currents might induce temporary magnetic shields, flickering on and off like cosmic lightning. But perhaps the most tantalizing question of all is habitability. We've long assumed life needs a star's warmth to thrive, yet signals like the neutrino rain of OGLE-2012-BLG-1928 suggest rogue planets might harbor their own heat sources, whether from radioactive decay or tidal friction. Combine that with the diamond dust echo of WISE 1405 plus 5534, which implies crystalline subsurface structures capable of trapping liquid water, and suddenly these wandering worlds don't seem so inhospitable. Could rogue planets be stealth arcs for life, drifting between the stars with ecosystems hidden beneath their icy crusts? It's a radical idea, but with each new signal, it's getting harder to dismiss. What's clear is this: rogue planets are rewriting the rulebook. They challenge us to abandon Earth-centric thinking and consider possibilities we've never dared to before. And as our telescopes grow sharper, one thing's certain: the universe still has plenty of surprises up its sleeve. So, what do you think? Are these signals cosmic anomalies or clues to something even bigger? Let's keep the conversation going below, and don't forget to subscribe for the next chapter in this ever-unfolding mystery. The cosmos isn't done teaching us yet. Now, let's turn our attention to the elephant in the cosmos. Could any of these bizarre signals be evidence of extraterrestrial intelligence? It's a question that sparked heated debates, and frankly, it's one we can't ignore. The idea of alien megastructures or advanced civilizations lurking on rogue planets might sound like science fiction, but when faced with signals like the Morse-like dots of WISE 1711 plus 3500, or the Fibonacci sequence from WISE 1828 plus 2650, even the most skeptical minds pause. First, let's tackle the Fermi paradox angle. If the universe is teeming with life, why haven't we found undeniable proof? Rogue planets could offer a twist to this old puzzle. Think about it, these nomadic worlds, untethered from stars, might be ideal hideouts for civilizations seeking longevity. Without a host star's volatility, they could avoid supernova, solar flares, or other cosmic catastrophes. The vanishing signal of WISE 1952 plus 7240, which disappeared mid-study, fuels this speculation. Was it a malfunction or something deliberately shutting off the lights? But before we jump to conclusions, let's weigh the natural explanations. The spiral code of MOA 2011-BLG-262, for instance, mirrors plasma spirals observed in neutron stars. Similarly, the duo whistlers of WISE 1541-2250 could simply be rogue planets amplifying ambient interstellar noise like celestial feedback. Even the Fibonacci pattern might emerge from chaotic atmospheric dynamics. Nature loves fractals after all. That said, the sheer diversity of these signals keeps the debate alive. The chromatic beacon of PSO J030947.49 plus 271757.31, shifting colors like a cosmic traffic light, doesn't fit neatly into any known astrophysical box. Could it be a beacon, a navigation tool, or just an exotic atmospheric prism effect? Here's the key: skepticism and wonder aren't mutually exclusive. Dismissing every anomaly as just weird space stuff risks closing doors to groundbreaking discoveries, but attributing them all to aliens overlooks nature's boundless creativity. Maybe the truth lies somewhere in between, a reminder that the universe is stranger than we imagine, whether it's filled with life or not. So, what's your take? Are we hearing the cosmos's natural symphony or something more deliberate? Drop your thoughts below and let's keep exploring this mystery together. The answers, or perhaps even bigger questions, are still out there. As we wrap up this cosmic journey through the unexplained signals from rogue planets, one thing becomes undeniably clear: the universe loves to keep us guessing. From rhythmic pulses that defy known physics to eerie whispers in the void, each signal we've explored today is a reminder of how little we truly understand about these nomadic worlds. Whether you're team natural phenomena or team alien megastructure, the mystery itself is what makes this exploration so thrilling. Think about it, rogue planets drifting untethered through the darkness might hold secrets that rewrite our textbooks. The vanishing signal that disappeared without a trace, the Fibonacci sequence that mirrors mathematical artistry, the chromatic beacon that dances with color. None of these fit neatly into the boxes we've built. And that's the beauty of science. Every anomaly is an invitation to dig deeper, to question and to wonder. But here's the best part: this isn't the end of the story. New telescopes like the James Webb Space Telescope and upcoming missions are poised to peel back even more layers of these enigmas. Imagine what we might discover next: a signal that finally cracks the code, or perhaps something even stranger that leaves us with more questions than answers. Either way, the adventure is just beginning. So, what do you think lies behind these cosmic riddles? Have we stumbled upon nature's most elaborate quirks, or is there something or someone else out there? Drop your wildest theories in the comments below. Let's keep the conversation buzzing. And if you're as hooked on these mysteries as I am, don't forget to hit that subscribe button and ring the notification bell. There's a universe of wonders waiting to be uncovered, and I'd love for you to join me as we explore them together. Here's to the next great cosmic reveal. May it be as mind-bending as the signals we've shared today. Until then, keep looking up. The stars and the rogue planets hiding among them have so much more to tell us.